Right. So now we know what we are trying to do here. In this video, we're trying to load pre-trained weights from OpenAI. We've discussed why we would want to do that. And now let's see how we can, because we actually created this model, the GPT model, our version of the GPT-2 model. And we slightly trained it on, it was a very, very small text with 5,000 tokens, and it wasn't performing well. So we said, okay, let's get the weights from OpenAI, where they used hundreds of thousands of dollars to train their GPT-2 model. Let's just get those weights because they were gracious enough to release them. Unfortunately, at the time they trained using TensorFlow, so we are going to install TensorFlow for that reason. And so this is just the version that I'm using. And this block here, it's a bit complicated, but essentially it's just downloading the weight. So you can run it as is. You do not need to think about much here. We're just downloading. And the sizes, they released the 124 million parameter size, 355, 774, and the extra large, which is 1.5 billion parameter model. So that's what it's just going. It's just going to OpenAI, the public website, and downloading them. So don't stress much. It's just a utility function. That's all it's doing there. What is important is now this is, yeah, yes, it's now downloading. So we have the settings and the parameters. Let's look at the settings. So the settings, you can see that we have end vocabulary 50,257, like we've been talking about. The context length is 1024. Number of embeddings is 768. Number of heads is 12. And the number of layer is 12. And here we're just downloading the 124 million one. That's the one that we have chosen. But if you have a machine that is good enough, you can even download the 1.5 billion one. It will have different number of heads here, number of layers, and number of embeddings and all of that. It will be slightly different. So here we're just using the 124 million parameter one. That's why I said that that one, that download and load GPT-2 is a utility function. You can just copy paste the way it is. It'll give you this. And if you're keen-eyed, you see that this actually looks like our n config, our config that we've been using. Because in our config, we've been using something like this. They're just written slightly different because of the naming that they used as OpenAI. But the number is just the same. As we had context length, we had embedding dimension and stuff like that, but it's just the same. And we were using 256 just because we had that training part with the verdict text. So we needed at least some dimensions that we can run on our machine. But the number of dimensions that they're doing is 768. So we need to make sure that we observe that in our GPT model. And the parameters. So we downloaded the parameters as well, which are the weights. So the parameters are the weights. But what are the keys for the parameters themselves? So we have blocks, BG, WPE, and WTE. Those are the parameter dictionaries, dictionary keys. Cool, perfect. And this is the weights for the positional embeddings. We know positional embeddings are needed in our transformer block. And these are the token embeddings. We also know that token embeddings are needed. Oh no, it's not really in our transformer block. They are needed in our GPT model because they are before we actually apply the transformer block itself. After we add these two, the token embeddings and the positional embeddings, they get normalized and all of that, and then we get into the transformer block where we'll start working with these blocks and all of that. But let's just see. These are the token embeddings. So the token embedding weight dimensions, we see that the shape is, of course, going to be 50,257, and the dimension is going to be 768. That's just the shape of the WTE. Perfect. If we are using 355, we can just change the name and they'll give you different ones. So this is what we are actually trying to do here. We are actually trying to say, okay, token embedding layer, positional embedding layer. Those are the ones that we just seen now. And then we'll get into layer normalization. And we now want to get to load the weights that are going to be in our multi-head attention. You remember multi-head attention, we have WKV. We have our, yeah, our KQV, in our multi-head attention. And we have some number of heads in there. And we are going to repeat this transformer block by the number of layers, depending on the model itself. And that's it. So let's see how we are going to load the weights into there, because we have already created this architecture. We've created this architecture, but it had some randomly instantiated weight matrices. Let's now see how we can inject the weight matrices that are correct. So we have this config. So we are just defining the config file. If we call this key as it is written here, it means the what we want is the embedding dimension of 768 with 12 layers and 12 heads. If we call this key for the medium, we want 1024 embedding, 24 number of layers, and 16 heads. It's the same thing with the extra large. So now that we have that, the model name that we're going to use is going to be the key. So here we're only using the GPT small 124 so that we get this as our config, right? Perfect. So we are going to say our new config. You remember our old config that we had with the 124. We're just going to copy that one. But then we are going to update that new config. We copied it as the old config, right? But we are going to update the new config because now we have some parts that are different. We're going to update the model config using this model name. So we are going to update it with saying the embedding dimension needs to be this, the number of layers needs to be that, and all of that. In our new config, we are also going to update the context length, because here we do not have the context length. In our old config, we had said the context length is going to be 256. That's what we had said, right? Because we just wanted it to be easy to deal with. But now let's update our context length to be equal to 1024 to align to what the context length that GPT-2 was using. GPT-2 was using this context length of equal to 1024. That was the context length. So let's align so that everything is the same before we load our weights. And then they also used KQV bias. They had the bias layers, but the bias research has shown that the bias is not really important. But GPT-2 was trained a couple of years ago, and people still thought that the bias will help. So we'll just activate it to true, even though in our original config it was false. We just activate it to true so that we align. Now we are creating our GPT model with our new config. It's the same way as if we're creating a new GPT model with the old way, with the old config. Nothing different there. We haven't started loading anything crazy yet. Not yet. We're just putting it into evaluation, into eval. Because we do not want to train it, we're just putting it into eval. We're not going to be able to train this model, right? So let's put it into eval. Now we are loading the weights. What we're going to do is we're going to take, because this model has been instantiated with some weight matrices that we want to replace with the actual matrices from OpenAI. We're just going to use this as define it as an assign function, just to make sure that we're doing things correctly. The reason for this is because OpenAI called their matrices using different words. So when building this function, it was a trial and error. It's like, are the shapes matching? If the shapes are not matching, it means we are actually trying to replace this matrix with the wrong matrix. So it was trial and error. So that's why this assign is there, just to make sure that everything aligns. Everything aligns. That's it. So if in the left side will be our model that have been our matrices or our parameters that have been instantiated in this step that are just random. They've been randomly chosen. You remember, we randomly instantiate a model. It's not performing well. This one, if you try to run it now, it doesn't perform well. It to tell you random stuff because it's not trained, right? We are now replacing those weights or parameters with OpenAI's trained ones. So we're just going to say if our left side, the parameters that we want to replace are not equal to the right side that we're bringing in from OpenAI, then just give us an error that there's a mismatch. And we can try some things. We can try some things to say, okay, maybe we are replacing it with the wrong matrix or whatever it is. But I assure you that this has been, the trial and error has been done already, but for your comfort. And then, so that is this part. But the other important part is we're just going to return. So if this is passed, we are now just going to return the the right side, which is coming from OpenAI. When that is returned, then that gets put into our model. And our model, our vanilla model, gets updated with those weights from OpenAI. Nice like that. So let's start loading the weights. So this is the function that we're going to use. We have our GPT model here that is some random parameters that have been instantiated, and we have our parameters that are coming from OpenAI. As you remember, the parameters are coming from here. We have these params. These are the parameters that are coming in, and these are their keys with their positional embeddings, weight embeddings, blocks, and all of that. Cool, perfect. So we know that we are going to do the positional embedding. So for our GPT positional embeddings, let's assign, first we are going to assign into our positional embedding, we are going to assign the positional embeddings from OpenAI. That's it. And the assign will check if the two are matching in shape. Yes, they are matching in shape because we know the architecture. We just created the right architecture as what OpenAI did. We are now just replacing the parameter values with what they had. That's the same thing with the token embeddings. We get the params token embeddings from OpenAI. And this is what you will do when you get open weights. When you get open weights, they might be in another separate params file. You will build the architecture the same way that the researcher has done. And it will be this shell here, this vanilla that is random stuff. And then you get their params, you get their parameters, and you start replacing bit by bit, bit by bit, bit by bit. So now by the end, you have an exact copy of the checkpoint that they had, that they released. That's all we are doing here. So now, after running this part here, our positional embeddings are now having the same weight values as OpenAI's GPT-2 and not the weight values that we had instantiated here. I hope I'm making that point very clear. And then now we are saying for each block that is in the number of blocks, params, how many, however, blocks we are going to have. We remember that we have our QKV. That's what we are creating here. And in OpenAI, they put all the QKVs into this W here. As you can see, it's part of the blocks because we are now dealing with blocks. And then B, the attention part and the causal attention, and they put them, all of them into W. You can print this part to see that it's actually, it is, it is, it is, it is, it is a multi-dimensional one that is multiple blocks in it, and each block will have one that is all the KQV into one. So that's why we're splitting them. We're splitting them into three. And when we split for each block, when we split this W, we are going to get our WKV for that particular block because we are doing for B in the blocks. So another block we have its own WKV, another block we have its own WKV, 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 like that. But then for each block, we have our WKV. I don't know why I keep saying WKV. QKV. QKV. We now have a QKV. Sorry, apologies if I caused any confusion when I was kept saying WKV. I meant QKV. Now that we have our QKV, we then say for our GPT model, we want our W query, our WQ, the weights themselves to be assigned the the Q that we have extracted from OpenAI, and our WK weight to have the K that we extracted from OpenAI, and our value to have the V that we extracted from OpenAI. Easy peasy, straightforward. Now we have our KQV matrices. And then we go on again to do because these are repeating, we do the same thing here. We have we have biases. In our case, original case, our GPT didn't have bias blocks. It didn't have bias blocks. But in GPT-2, when OpenAI trained it, they had bias blocks. That's why in the model that we had, we've been learning about, we didn't have these here. But now we do have them. So let's just apply them the same way. Our query is bias Our key is bias and our value is bias. Same way, we are just going to say QB, KB, VB, splitting the bias now. Splitting the bias, the B, and not the W like we split there into K, Q, V, but the bias terms. Perfect. And then this out projection is just going to be our out, at the end of these blocks here, transformer blocks, we have an out, right? So we have an out, some out layer. We are putting their weights here, and then we assign the C projected layer. Same thing. We just assign it there, C project from the blocks and attention blocks here. We're not doing C attention anymore because the the last part, outside the transformer, outside this block, the attention masked attention. We do not. We are now outside the masked attention. This was the masked attention part. Now we are having this output layer. Perfect. So it's going to be that, and then we are going to have our feed forward. You remember we had our feed forward. So our feed forward, we have its own weights and its bias, and then we have another layer two with its weights and its bias. Great. That's the same thing that we're having here. It's the same thing that we're having here because we have those in the feed forward. We have the two layers, right? And then we have our norms. We have a norm that is there. We have the norm one, the scale and the shift, and the norm two, scale and shift. We've discussed norms before. That's what we are having there. And then the final norm right outside these transformer blocks, because now we are outside the transformer blocks. We are now just finishing off the GPT model. And then the final norm, we have a final norm. That's what we are getting here, the final norm. And then we have our shift for the final norm. And then the out yet, the actual out layer head, the out layer head that does the predictions and gives us a logics and all of that stuff. It's going to be this one here. That's it. So now we just apply this load weights, this function that we created here. Into we load into our GPT these parameters from OpenAI, and we put our GPT to whatever device we have access to. If we have loaded correctly, let's apply now our generate function. You remember, even though we tuned it and then we had used our top K and our temperature, it wasn't really doing well. Let's now apply it when we say every effort moves you. We tokenize it. We ask for 25 new tokens. We apply our new config, not the old config, with a new context, with our 1024 context length. Top K, we are saying 50 and our temperature of 1.5. Let's see what the output is. So you can see it now says every effort moves you as far as the hand can go until the end of your turn, unless something interrupts your control flow. As you may observe, this is now very coherent. It's well coherent text. It's saying something that I can understand right now. And that is the beauty of open source. I want to just emphasize that right now. I want to take this opportunity to emphasize the beauty of open source. When Llama came out, AI blew up. This type of AI blew up because they open sourced their architecture and open sourced their checkpoints and open sourced their weights. So anyone could create a version of their Llama that they did. I'm very grateful that OpenAI released their GPT-2 model like this. We know the architecture and we have access to their weights, which means now I've access on my computer right now. And on your computer, you have access to GPT-2 that you can run, which is just brilliant about open sourcing these things. So that is what we have. That is what we have here. And I think it's amazing. So what that means now is we have a well-trained GPT-2 model. So let's see in summary what we're going to be doing, because the next video is just a summary.